to Dr. Howard Wu from ANTOBOT, who developed a solution which was, can you create a solution which automates manual processes for horticulture? So the judges for this session were Grimet, NFU, KTN and Bardsley, England. So Howard is a chartered engineer and a strategist, 20 years experience in embedded control systems, vehicle integration, product planning and business strategy. So he was a research associate of the vehicle control system for China's first fuel cell city bus during 2001 to 2004. He then served as a vehicle architecture engineer and vehicle integration lead at Shanghai General Motors before moving to the UK in 2006 for his PhD research at the University of Cambridge. So he joined Ford Europe in 2010 in powertrain control system engineering, then global product planning and business strategy and European Mobility Innovation Centre. In 2018, Howard joined Monitor Deloitte's London office, providing strategic consulting services for automotive and mobility industries, clients including Jaguar Land Rover, Mitsubishi Corporation and Dyson, among many others. So he is now the co-founder and CEO of ANTOBOT Limited, an award-winning robotics startup based in Cambridge and Chelmsford, with a strong focus on the agriculture mobile robot and its key component, the robot control unit. Howard holds a Bachelor's of Engineering and a Master's of Engineering degree in automotive engineering and a PhD degree in engineering from the University of Cambridge. So Howard, we can see your screen. It's over to you. Off you go. If you wouldn't mind turning your video on, if that's possible, that would be great. Hi, Howard, that's great. We can see you. We just can't quite hear you yet.
Okay, can you hear me now?
We can hear you now, Howard. That's brilliant. Thank you. Off you go.
Okay, excellent. Thank you. First of all, I would really thank you for give us the opportunity to present our project in the meeting today. And it's our great privilege being selected as the winner of the Hackathon Challenge 2. As I understand, it was a very competitive competition. We feel so lucky and so privileged to be selected. So in the next 20 minutes or so, I will take you through the project we proposed to address the challenge in the labor shortage in the horticulture sector. And when I talk it through, I will also mention a few things our company, our startup is working on. So as you are aware of, in the horticulture sector in the UK, it has been the labor shortage has been quite a big issue due to the Brexit and also recently because of the COVID-19. Actually, we believe this is probably a long trend rather than a short impact. Because of the aged population and also less interest of the younger generations in the field work in horticulture sector. So in the past few days in the hackathon, we come up with this solution to address the challenge. As you can see here on the screen, our solution is a Orcharbot, solar-powered and net zero agriculture mobile robot. What we do is we take a modular architecture with a platform design. On the left-hand side bottom, you can see this mobile robot. This is the solar-powered and 5G connected always on. On top of this mobile robot platform, we propose two robot concepts. The first one is the crop squatting robots. So we add the squatting cameras on this mobile platform. Then using the vision system, we can detect pests and disease, as well as counting fruits, vegetables, and also sizing. The camera will be mounted at maybe around 2 meters high if we are in the orchards, for example, in apple or pear orchards, but it's also adjustable. We can lower it down for example, 1 meter above the ground, so we can take a look at the strawberries in the tabletop planting system. The second robot concept is the weeding robots. So still on top of this mobile robot platform, we propose 3 different eco-friendly weeding mechanisms. The first one is a mechanical version, which would be good for the organic crops. And the second one will be a precision weeding spray, which could substantially reduce the herbicides required. The third one is electricides. There are some UK companies are pioneering this new technology to get rid of the weeds organically. And also on top of these 2 robot concepts, we also have a premier feature we are thinking might be useful for the robots to improve its utilization rate. That is the variable track width adjustable system. If you imagine you are growing onions or lettuce or other vegetables, they probably have different row widths. So to make the robot is more generic, more usable, then this track width adjustable system can change the track width in a few minutes. So you can apply it to many different crops. So this is the concepts we're thinking could be applied to address the labor shortages. And then what we are thinking is how to really implement those concepts into a real products. So now I talk a bit about what our company has done in the past about 2 years. So these are the key building blocks we believe be ready to for commercialization and to make those robots. The first one on the left-hand side is the universal robot control units. This is a all-in-one design to meet the demanding in the agriculture robotics applications. So we have managed to integrate the AI chips and automotive-grade real-time controllers into one single unit. So it's faster and it's smaller. We also integrate the RTK GNSS, the IMU sensors, and the communication capabilities into this unit. So with just one unit, you can basically meet all the required functions for the agriculture robots. The second bit we have done in the past, we call it AntMove. It's a navigation, robot navigation software stack, as you can see here. So it's based on the RTK GNSS, LiDAR, and the camera. So this is the navigation stack. We can drive our robots on the field automatically. The third building block is here. It's a DNA. It's a deep neural network-based computer vision module. So we developed this for strawberries. We can detect a segment and locate the strawberries, give you the size, and also can count in the fruits. Because it's a deep neural network, we can easily be extended to other fruits and vegetables. For all of these 3 key building blocks, we are ready from technology point of view and could be used to build the robots, the mobile robots we talked in the previous slide. Just a little bit more about the technology readiness. So we are collaborating with the Bristol Robotics Laboratory. They have already developed an automatic weed imaging and analysis system. As you can see on this picture here, using the machine vision pipeline, they can identify the weeds precisely on the ground. And then with the concepts we developed earlier, so we think we can develop 3 interchangeable weeding systems to meet the different weeding needs at the growing cycles of the different crops. But this one, at this moment, it's still early stage. It requires a bit more development or collaboration with the companies has expertise in these areas. The last one here is about end-to-end learning while teleoperation. So this is something we believe could be very useful in the future to leverage some very advanced research in Bristol Robotics Laboratory. So we can make the robot to learn more skilled and more complicated tasks by learning from the human operations while the operation. So those are the technologies and the robot itself we are proposing for this challenge. But actually, think about the whole system. The robot is just one element of the system. So as we are showing here on this chart, so it will be a fully integrated data and service system. So the robot can collect probably a huge amount of data from the fields, like the disease, like the pests, like the growing status of the crops, and then it can upload those data into the cloud. And for the farmers, they probably can use an app on their smartphone to understand how it's going on in the fields, and also planning some tasks for the robot from their app, and also probably can engage with some supply chain negotiation with the downstream companies like supermarkets. To make this happen, it's quite a big scope. So we think we will leverage the platform, the existing systems to make it more feasible, such as the Google Map platform, such as the Amazon Robot Maker. So then we can probably build a much more open API and data interface. So those data can also be used for other data users, like the supermarkets, like the insurance companies, also like the end consumers. So one of the very interesting trend recently is on the consumer side, the people, the consumers, they are very keen to understand how their food are being treated and being grown. So if we give them this visibility and traceability, I think that would be a very positive insight for the consumers. That will also benefit the farmers if you can provide that kind of visibility and traceabilities. And all of this will probably not be able to happen just by ourselves. So we think there will be lots of collaborations between different players in the ecosystems. There are a few existing open data initiatives in food and agriculture, and also as I am aware of, there is a new one called Feed UK is also starting to be initialized. So we think there with the players in these ecosystems, with the collaboration, we probably can make this happen in a more accelerated speed. So talked about the robot itself and the entire solution. I'd like to probably show you this user journey. We are trying to use the technology to solve some problems rather than to use the technology to find the problems. So from this point of view, a really user-friendly interface, user journey is okay. So here is a little video we created in a short period of time. Just want to show how it may be look like from the farmer's point of view. So on your mobile phone, you probably can have this app showing your farms and give you some information about when last time your crops has been checked and the weeding has been done, and also probably give you some availability to apply your next tasks as well. And also on this app, it can give you the status of the robots working in your fields, how its status and where it has been. And when you think you want to do some new tasks on your fingertips, you just put down the dates and the things you want to do. And it can also give you some real pictures from your fields. And also, if you would like your robots to go to take a look, for example, particular areas in your fields, you probably on your fingertips, you just draw the route the robot will go. So this is some user interface we are imagining could be very convenient and something you can probably easily done in your living room when you are sitting on your sofa. So go back to our solutions and the robot. There are a few competitive advantages we believe we can create. The first one is net zero. We are proposing a concept that will be purely driven by solar power. So that means it's zero emission and also will be zero energy cost. And then we will leverage the engineering know-how we learned from the automotive industry, such as the lightweight and robust structure, as well as automotive level hardware and software. We also integrated some functional safety mechanisms in our main controller, so that can add additional safety protection for this fully autonomous robot. The robot, as you probably would expect, it will be 24 hours a day, 7 days a week to operation. And utilizing the data we can collect from the robot, we can do the predictive maintenance while analyzing its status from the cloud-based database. So that makes sure we can work with service those robots even before its breakdown to improve its work with on time. This is some very preliminary study we have done from the business model point of view. So we are thinking to do a farming as a service to keep the business simple. We understand farmers have very busy life, so we try to make things simple. And it's basically like a subscription. You pay like a monthly bill, and we will look after those tasks like crop squatting and organic weeding. Those numbers are very preliminary, so we will need your inputs, especially the farmers online. We really welcome your inputs on the business models and how you would like this being done. In terms of the timing, based on what we have done already for the robot control units and for the for the vision model and the navigation module, we think it probably will take us about 1 year to develop those robots, and then we can probably get into some pilot programs, and then probably commercial launch in 2022. But one of the nice things to do this with the machine learning is that it will be a continuous learning and improvement. So the function and the performance of the robots will become better and better when we are using it. Some preliminary figures about the market size. So we have done very high-level estimation. From the horticulture point of view, the UK market is probably about 100 million. Globally, we don't really have much data to support that. We have made a very bold estimation based on UK's horticulture, probably about 1% of the global horticulture sector. So we times 100 to get the global market size roughly. And here is a very early financial projection. So as a project or as a business, we want to survive, and we want to make a win-win situation. So firstly, we want to make real benefits, real saving to the farmers. On the other side, we want to be sustainable for our own projects and the business. So roughly, we estimate about 3 years. In year 3, we can do a break even, and after that, hopefully, it will be into a good shape. In terms of the social and the economical impact, so this is something we took very seriously when we started this hackathon. I think firstly, as the robotic solutions, we can mitigate the pandemics such as COVID-19, as we can reduce the human contacts to reduce the interactions between people. Secondly, for the climate change, I think this is probably one of the most significant challenge the whole human being are facing. With the solar powered solutions, we can significantly reduce the greenhouse gas emissions, as well as those pollutant emissions. In terms of the food security and sustainability, I think there are two things we are thinking of. One, with the eco-friendly weeding, we can probably substantially reduce the herbicides and pesticides usage. And secondly, with solar-powered robots always in the fields and monitoring the status of the crops, we can detect disease or pests early, so we can get them being treated early. In that way, we can probably also reduce the chemical usage. The last but not the least is the aging society. I think globally, almost every country is getting older, which is a good thing because people are healthier and live longer. But on the other side, it put more pressure on our food supply chain. I read some news recently. The median age of the UK farmers is about 60 years old. And for the younger generations, not many people are really interested in this. So hoping by doing more robotic solutions, we can make the jobs more interesting and more fun, so we can attract more young generations to get into this sector.
Howard, do you mind if I just jump in there? It's a fantastically detailed presentation, and you know, as winners of the hackathon, you've developed some fantastic solutions. We have run quite far over time, and a lot of questions have rolled in for you as well, actually, Howard. So what I'm going to do is I'm going to get our hackathon team to send them across to you after the presentation. Do you mind if we move on to our final speaker? Is that okay?
Sure. Yes, of course. I thought we got half hour. Okay, sorry about that. Yeah, of course.
Thanks very much, Howard, and you know, congratulations again, a fantastic solution. And like I said, a lot of questions have come in, so I'll send them straight over to you to address. A lot of people very interested in the development of Orcharbot. So finally, for our closing remarks, we are going to move on to Vince Gillingham, but before we do that, I do really just want to thank all our delegates and all our panelists and speakers for today.